All right, welcome everybody to our brand new N2E Workshop. Today we're going to be talking about segmentation and computer vision. I'm Aditya.
And I'm Vincenzo.
And okay, here we go. So firstly, what is segmentation? Essentially, the whole goal of segmentation is to take any image that you're given and partition it into multiple different segments to make it easier to understand. And the way it's done is first you take the image, you assign a label to every single pixel in the image, and any group of pixels that are assigned to the same label becomes a mask. And the main use cases of these would be one, to detect objects and be able to mark wherever they are in an image and separate every distinct item in the image. And the main applications would be in medical imaging, autonomous driving, for example, the image shown here, and image editing, where identifying and separating different masks is crucial. That being said, today we're going to be exploring Meta's SAM2, which is currently the best segmenting model in our opinion, in terms of its accuracy and speed and efficiency, and how scalable it is for real-time applications. And not only can it segment images like shown here prior, it can also segment videos, as you can see there. Yeah, they have a memory encoder that stores the frame information and makes it so you can have accurate predictions across multiple frames. But to get started, we'll discuss the main things we're going to go through in this workshop, which would be setting up Python, Git, VS Code, which are the essentials not only for segmentation but for any computer vision or any projects, any coding projects. And then we're going to set up SAM2. We're going to segment a picture, and if we have time, segment a video.
Yes. So let's jump right into initial setup. So I kind of came in with the idea that we weren't too familiar with setting up projects and playing with different environments. So I'm taking you through the basics, and then we'll go into SAM2. So if you haven't already, assuming that you're not familiar with setting up the interpreter, I recommend we're going to install Python. Now, if you're a Windows user, the most important aspect of setting up Python is ensuring that you have Python added to the path, as when you set up in the terminal, when we set up for VS Code, you'll be able to access it from the terminal. So from the slides, you can go to our link and you can download the latest version of Python. Select the executable. And then we already have it installed, but typically you would have an option at the bottom to add the path and install the program. Yeah, we can just close it. Yes. Awesome. After you have Python set up and installed, you're going to want to install Git. For this project, we're going to use the GitHub desktop environment. I'm assuming most users here either using Mac or Windows. So you don't.
Different based on.
Of course. But if you aren't really familiar with using Git, I think this is probably the easiest step. GitHub desktop is a really useful tool that allows you to download and install environments. So to just give a quick rundown, we're going to download our executable, open when completed, and from this executable, you would install the program. Give it a moment. Yeah, we already have it installed, so you would just enter the prompts and say, yes, I'm interested in installing it, and consider all the basics. Keep all the basics as is. I might be reinstalling it over our installation.
Yeah, I mean, maybe we should have uninstalled the prior ones and just do it, but it's
not that big of a deal. Okay, cool.
I think it installs it over.
So yeah, so what you would typically see, as we can see, I'm logged into my account and I don't know how to log out. You would be prompted with an option. Sorry.
Oh no, well, I'm just saying if you have this, since this is not the first time downloading on this device, Vinny's already logged in, but if it's your first time, you'll probably get prompted to log in with your GitHub account that you already have prior.
Yeah, and if you don't, you can just create a GitHub account and then enter your credentials from there.
This is just a much easier way to push and to see changes in any repositories that you would download or work on in the future.
Yep. From here, I'm going to assume you have an installed VS Code. So if you haven't already, you can just select the link and download for your browser, and it'll automatically install. Once installed, you're also going to want to install the Python add-on. So if we hop into Visual Studio Code real quick, we can click the little boxes on the side and type in Python and be able to install our Python right here. All right, cool. Now that we have everything installed, let's go to get the GitHub link. So I'm going to right click on here. And this is the SAM2 repo. SAM2 has, as previously highlighted, a myriad of features. Namely, it has very good segmentation in its model as it was trained on a large data set, as well as with the addition in SAM2, it does segmentation tracking, I think is the best way to describe it, where if you provide an initial frame and then an end frame, SAM2 will attempt to predict the in-between frames and follow a particular object, as seen in some of the examples right here. So what we're going to do is we're going to select our link up here, copy, go to GitHub Desktop. We would go into right here. So make a new repository. Yeah, that's fine. I'm going to remove this repository and move it to the bin. Oh, it's open in VS Code. Apologies. I'll just close all windows. Don't save.
Yeah,
and then I'll remove it again and remove. Good. And this is what you should see. From here, we're going to go into create clone a repository and do URL. And we're going to do Control V or right click and paste. And from here, we'll go into clone. This will copy the SAM2 repo directly from the GitHub. Yep. Awesome. And then we'll wait. It's taking a minute. Well, while that's running in the background, I believe we should also, I'm going through the clone the repo step. We'll go into this repo step momentarily, but while we're waiting for the repo to set up, we're going to go to this link right here. This will install the SAM model. The repo doesn't include the SAM model, so we haven't provided the download link. If you were on Linux, you could run the script provided in the GitHub repo, but this link will just suffice as well for the model that we're playing with. Awesome. So the repo is set up. We're going to go into here and select Open in Visual Studio Code. So this is your environment. We're going to go up here and select Terminal, New Terminal. To ensure Python is installed in our Windows environment, we can type Python space -v, a capital V. It is not installed. Oh no. No, I checked before too. Okay, it just works now.
What did you do?
I classic close it and open it.
Well,
the rules of IT apply to many different things. Anyway, we're going to install this line in our terminal. This will install all of the necessary packages to run SAM2. I definitely did this first try. Well, while we're waiting for that to set up, there's going to be there's 3 tools and 3 notebooks that you'll be able to play with for future reference. There is the automatic mask generator, where if you provide an image, it will automatically generate all potential masks that it thinks are within the image. This is an example they provide with the car image, but this is run all on local hardware. Very cool. There is the image predictor, where you can specify more specific parameters to highlight particular regions of interest within the image. So take, for instance, the image highlighted the car wheel rather than the entirety of the car. And further, while we won't really cover it in detail, there is a video predictor where you can provide an initial frame of an image in a video and provide an end frame, and it will attempt to predict and follow the segmentation across the entire video set of frames provided. So we'll wait for this to install. We're going to be here a little while, I believe. There we go.
All it needed was a push and shove.
Yep, classic. And there we go. SAM2 is set up. Then we'll only do one last thing. We'll take the model that we downloaded earlier and we'll place it within our checkpoints path. So plot it right here. For the sake of consistency, I'm going to remove that parenthesis 1 at the end. And there we go. So we should be set up and good to go. So I'm going to go into automatic mass generator example. It'll request you to declare your environment, and you will declare the environment that we have set up right now for real on our first try. We're going to hit no to collab. We're going to set up our environment to confirm if we have torch available. And we do, because I have a 2060 in here.
You can just run on.
Oh, yeah, run off. Yeah. I just wanted to go through each one and briefly explain it because nobody else here. So this is checking what graphics to use. I guess we're using CPU, doesn't recognize my graphics card. That's fine.
Wait, go.
It's using CPU.
No, I know. I want to see. Oh, no.
That's fine. We have the image initially. And then as we can see right now, it's taking a minute to generate the mask. Within the code itself, it's segmented, pun intended, into different objects. There's the segmentation mask, there's the area the mask takes up within the image, the bounding box of that segmentation, and then how the model provides a predicted intersection of the union, how confident it is found the entirety of the object of interest. And then point coordinates will come more into play in the second notebook, and then stability score is another mask quality check, and then the crop to generate the mask. So we'll wait a minute or two. It takes a little while. It didn't generate yet. It's still running that top code.
Oh, is it? This is the previous one?
Yeah, it was the previous one.
I see.
It takes a minute when you're generating all the masks for an image. And it takes even longer when it's using the CPU for some reason.
Did you use a GPU when you were making it?
Yes.
Yeah, it just decides to not.
It was not. Last time, the last lab. Yeah. I did Windows on purpose because last time I went to the N2E, everyone was either Mac or Windows.
You also need to.
You could do Zoom on Linux. That makes too much sense. We could have done it that way. I think I still have the. Yeah, that's fine. Yeah.
I guess we could edit this ourselves.
It took 2.5 minutes when using CUDA. Now it's taking 2 minutes using CPU. Over 2 minutes.
Oh, there we go.
There we go.
And here is our segmented image.
Pretty cool.
Yeah, as you can see, there are some issues. For example, I don't know the exact word of what this is, but this one is part of the car, and this one is segmented as if it's something else. Some windows are not segmented, but the tree, the sky, again, parts of the tree are missing. But it does a pretty good job.
Yeah. Parameters that you might want to play with. For instance, maybe how many points you want, or how many points per side you want. What's your threshold for a satisfied segmentation?
Yeah,
it crashed my computer.
Anyway, let's go again.
So anyway, this is the initial segmentation with all the default parameters, but as we noticed, we can specify specific parameters to edit.
And if you change up the thresholds to be even more strict with the segmentation, you can see, especially the windows here, you'll be able to see that each separate window is segmented into its own mask, even in the car as well. So yeah, these are just something to play with, depending on what you're looking for. You could probably downscale your masks to, or increase your mask for better results, but depending on the situation. And yeah, now I think we'll go to the next notebook.
Yep, this one is more so if you want to specify, as we saw previously, SAM2 allows you to specify a myriad of parameters to either have stricter segmentation or looser segmentations. This is more so dedicated to allowing you to specify your segmentations even further to only segment specific portions or parts of the image. So one of the key things that you can observe is how, still set to CPU for some reason. Take, for instance, this image of a truck. We can go into SAM2, build it up with our large model, set our image, and we can specify an input point and associate it with a label. So notice here, we have our input point as 500 and 375, and we're specifying this window within the image. So if we were to run this, we have our window in the image, and then we can use our tool to predict and say, hey, find the segmentation with this particular point. And we should notice that it's only segmenting the window. Notice how you have different segmentations provided. Again, as mentioned previously, SAM2 provides a score for how confident it is in finding a particular segmentation. So as we can see here, the looser, the less smaller the score, the more, I'd say, loose our segmentation is. So for instance, in this first image, we just have the small window that is clearly has borders, to we have the entire window, to the entire vehicle. You can also provide additional points to specify like a larger range of the segmentation. So for instance, here we provide 2 points, and SAM2 decides to segment the entire vehicle. Now we are telling it to focus on a background point, which again is just that window, and to ignore the car. You can also specify with a bounding box instead of a point, like this tire. And you can combine the two to specify your segmentation to your heart's content. So for example, here's the tire wheel while attempting to ignore the rim.
Yeah, it's not. Star would be the ignoring. Star would be, you choose, the star would be what you ignore.
Yep. And then here is an attempt with multiple prompts. So we're providing a myriad of points and we're telling it to segment multiple things within the image. So now I'm saying, oh, segment the body of the cars, attempt to segment the individual tires. SAM2 is really good at allowing you to specify how detailed your segmentation you want and how many segmentations you want. It is important to note that this is not semantically segmented, meaning as humans we know this is a car, but the computer doesn't have an easy to access label to identify the type of classification this object is.
Semantic segmentation essentially is just an extra layer of segmentation where it'll label the mask, which is a very important thing in computer vision, since like when he said, we can determine what's what, but for example, the model won't know that that's a car and that's a tire.
Yes.
Sorry, I was pointing the screen. That's a car and that's a tire.
If you want to do something like that, it might be useful to use something like YOLO or deter. We have a video on our channel that goes into that topic with Takia, so definitely give that a watch. It is also possible to run SAM2 in an end-to-end fashion to allow you to batch over multiple images. So for instance, we have this grocery store set, and we're going to set the image. And as we can see, it is segmenting a myriad of images. We can also have a bunch of point prompts defined over a batch of images as well. So this is using bounding boxes.
Multiple images.
Yep. And then this is an example using just points. Pretty cool. There is also one more, but I'm actually afraid of running it because it was not able to finish and run on my computer. So I don't expect it to run on a common laptop. But more,
you know what I realized? They'll see the time being like, oh, it's 7:25 minutes. 7:40.
That's fine.
Yeah.
More or less, it's a similar setup, and I'm not going to go super into depth. But the main important thing is when you're going through video, you're going to have to go through and essentially separate each frame of the video directly. So in this example, they provide it, all the frames separated. But what is awesome is you can provide an individual frame to segment a particular object and tell SAM2, okay, given this object in the first frame, attempt to track it, akin to something like YOLO or deter. And it does a pretty good job, as seen in this example. So here it is at frame 0, frame 30, frame 60, frame 90.
Even when it's being covered, for example, in this one, the our mask was being covered, you can see that it still tracks it behind, which is quite impressive.
Yes. And this does it for a multitude of frames. You can also go in and further define your in-between frames of the segmentation and update your segmentation accordingly. And then you can propagate that across all of your frames for an even more accurate segmentation to the object you're interested in. And then again, just like in the image predictor, you can provide a bounding box, you can provide a point.
You can provide the point to ignore as well.
Yep.
This one has that one. That being the red star that we had, the images one, where you select the bounding box, but you unselect what you don't want to segment.
You can also segment multiple objects as well, as seen separately in the image predictor, to a similar method. So if you provide one image video frame,
yeah, that's the one.
Yep, you can segment a myriad of image video frames to keep track of both objects, like this shirt and this girl's shirt. And yeah, as you can see, SAM2 is a pretty useful tool.
Very powerful as well.
Very powerful, both conceptually and technologically, as we can see.
It can crash your computer.
It can crash a computer.
Yeah.
But yeah, that is our general demo for SAM2. If interested, I definitely encourage y'all to do our little challenges, which is just a simple task of just trying your own picture, maybe take a selfie or a picture online, a funny meme, and segment it as well.
The thresholds to get different types of segmentations on it. But yeah, I believe that is all for us. Thank you so much for watching. Bye-bye.